Hey everybody, this is Bobby Carlton, and I am joined by Pete. Pete, say hello. Pete,
Hey, how's it going?
Pete, what do you do for FS Studios? Let's give everybody your quick job title.
Basically, I'm a spatial engineer. How's
Oh, there
that?
we go. I like it. So this is Pete Switcher, and today we're going to talk a lot about digital twinning, automation, robotics, spatial computing, design, and a whole plethora of other information that we hope you find entertaining. When I was at South by Southwest, I recently saw an installation, and it was music, right? It was a band, and what they were doing was they were performing live. Meanwhile, the audience was wearing VR headsets. The whole idea was creating an environment where you could still feel the physical beats from the bass guitar, from the drums, and feel those sound waves hitting you like you were at an actual live show.
Yeah.
Um,
So they're kind of
Except
doing the
they were
flip
using
thing.
VR to sort of transport it. And I was thinking the whole time, I was like, imagine if like manufacturing companies or these warehouses or these sort of virtual worlds where the real world they actually had stereo speakers that sort of created a 360 audio, not just through your headphones, something that was like vibrates the floor, something that
Yeah.
like I think that
Well, and that
when it
and
comes.
that sort of hits on what we are talking about IMUs last session. Those are not only are they amazingly sophisticated, they're amazingly cheap. It's like a $5 chip that you can put. So people who are making equipment need to start putting those in their equipment, and they probably already do, but it's an internal diagnostic thing, like cars. You
Right.
know, how you take your car to a mechanic? Why? It sounds wrong.
It sounds
It's not like,
something
oh, I
feels
see
wrong.
smoke coming out the back. By then,
Yeah.
it's obvious to anybody. Way before that, you hear a difference in the way the engine is running, and they do have those they do that on trains and
Sure.
big equipment like that. They have vibration sensors. They monitor them all the time with software, but it's the immersion thing, right? In a big power plant or a big plant, like Tony, we're working with him
Yep.
on these big diesel generators, and those things, they've got hundreds of them. It takes hours to walk around in the yard and visit them all, but it's quite easily you can instrument each one, and then you could have a VR headset with the subwoofer, like I'm saying, and you could
Hmm.
basically toggle, go look at engine number 12, 13, and one person could kind of do the rounds of hundreds of them in a couple hours instead of
Instead of having
walking
to
around them
physically
taking all day
walk
or
around.
only getting half of
Right.
them done, right?
Right.
So
And you're
to me,
using
that's the
audio
future.
and yeah, you're using audio and visual experiences that sort of help do a diagnostic. I mean, just recently I was driving my car and it felt like it was pulling and rumbling. And so I knew I'm not a mechanic, but I knew something was wrong
Yeah.
based on that sort of tactile sort of experience, that bit of a rumbling. And you're right, the idea that you could eliminate the whole walking around with 100 generators, which is physically
And
a
that's
toll
sort of
on you.
why it's kind of inevitable, because basically it's like you can use this to save money and prolong the life of equipment, blah blah blah. So there's all kind of business reasons why it's a good idea.
Right.
Therefore, it will happen. You know what I mean? But it kind of gives us a segue to talk about spatial computing, which
Sure.
is where the IMUs come in, and that is the whole field that has opened up because of these cheap IMUs and also because of GPS. So we now have this concept called spatial computing, which means our
Hmm.
devices understand where they are in space relative to each other and to you and to the
Right.
world and all of those things. And that's enabled. It's enabled VR. I mean, basically the reason we can track where our controllers are, our hands are, it's part of spatial computing, right? But robotics, that's sort of my background, and robotics is inherently spatial computing. You take a robot arm, for example. What is the robot arm? Well, it's a bunch of
Mm.
positions of joints in space. What is the job of the robot arm? To move in space over there where that object is and pick it up and move it over there. Or I need in space as this car comes along, I need to weld these
Hmm.
joints in this position and that. So robotics is all about spatial computing, even though they didn't know it when they invented it. You know what I mean? Um, but now that we've come to this point in time, I mean, I showed you the demo last week where I'm trying to fuse VR and
Hmm.
robotics so that in my VR headset, I can see where the where it is and what the angles are and what it's doing without looking at a 2D screen and going, yes, the status indicates that it has picked up the
Right.
object. No, I can see it. It's picking up the object. You know what I mean?
Right.
So what that's going to translate into is AR headsets or AR glasses where I'm not looking at an RF. I don't, I, you know, in the example I showed you, I had to go and recreate my basement and
Hmm.
calibrate it. If you're talking about AR, you don't have to do that. I'm wearing AR glasses.
Right.
They are spatial computing again. They're doing something called SLAM. They're using IMUs and photogrammetry to basically build a map, a 3D map of the environment. We're soon going to be able to to synchronize my 3D worldview with the robot's 3D worldview, so that there's a lot of factories where people are working right beside robots, and safety is a concern there. The humans looking over here, they want to make sure that the robot isn't
Hmm.
arm isn't going to whack them in the head and that kind of thing. So it's important for the humans and the robots both to know where each other are. So we need to develop algorithms that let us build these 3D worlds and share them with machines. And that's what digital twinning is. So digital
Hmm.
twinning is I'm going to take the environment, I'm going to create a digital version of it so that anything that moves in it, first of all, it's the static geometry of the environment,
Sure.
but then there might be moving things in it. So now we need to put sensors on those things that move so we know where they are at any given time, right?
Right.
And then the other aspect of digital twinning is the robot itself. So we need to create a digital twin of that robot so that as it moves its arms and opens and closes its pincers and stuff, we have a digital representation of where what its state is, and then we can build with those things. Then we can present them to the human in either AR or VR or on a 2D screen. I mean, the 2D
Hmm.
screen's really, it's sort of boring, but on the other hand, it doesn't just have to be an overhead schematic. It can just be
Right.
like a PlayStation.
Hmm.
You
Sure.
play 3D games on 2D screens all the time. Just as an aside, if I say VR, that's what I mean. I include a 2D screen where you're going around in a 3D world.
Right.
But when I say VR, I mean virtual 3D environment that you can view either on a 2D screen
Or
or
through
on
a
a VR
headset.
headset or an AR
Yeah.
headset or whatever. It's the I should probably stop saying VR and just start saying digital
XR.
twin or
You can
metaverse.
say
But
digital twin. Yes.
every time someone comes up with something,
Yes.
it gets confused.
I recently heard digital. Someone referred to digital doubles recently, so I was like, "Oh my God, here we go again." But I get what you're saying, right? So and so in the world of sort of manufacturing and retail, how do you envision this idea of digital twinning playing a role as we move forward? Do you think it's going to be very important, or where do you think it's going to be?
Oh, it's absolutely important, and we've been doing it. I mean, the digital twin is just a new term for
Hmm.
using new technology to do things that we've been doing forever. I mean, going back centuries before engineers would build anything significant, they would model it, and that meant getting reams of paper and maybe an old quill and writing out a million different scenarios
Yeah.
and going, yeah, they'll probably work. nobody in any era of history was ever going to invest a whole lot of resources into building something if they didn't kind of know it was going to work. And the only way you know it's going to work, you build models, right?
Right.
Scale
Right.
models. There's a whole science based on scaling down mechanical engineering things and that kind of thing, and how the equations are affected so that you can
Hmm.
predict things. You know what I mean? You know, if you scale an airplane down by a factor of 10, then the wind, you know, like if to get it to fly 10 kilometers an hour is like flying 100 kilometers or 1,000 kilometers. There's formulas and they're not linear and
Right.
all that, but there's a whole science behind
Sure.
modeling. That's this sort of the engineering people. Then you have the marketing people, and they model everything too. So you could have a digital twin of a population. You know what I
Sure.
mean?
Yeah.
Digital twin is just another name for a model, you know?
Hmm. It's interesting. So, like, when you think about like the old days of car designing, right? Remember, you see those videos of people carving out pieces of clay, and they would carve out the car. Of course, if they needed to change something, they had to redesign a brand new car and recarve it out. But of course, with digital content, we can build the car in a make the digital twin of it, and then say, oh, we need to make the dashboard a little lower, and you can grab the dashboard, lower it, and you can then see from the driver's perspective, is it too high, is it
Absolutely.
too low, and it's done on the fly. And so that idea of digital twinning, right, play a big role in speeding up the process of
Exactly. Speeding up
creating.
the process. So to use your analogy of a car, nowadays, I mean, that's a perfect analogy because they do use VR.
Mhm.
The best VR headsets that we have,
Yeah.
that technology is kind of driven by car manufacturers and people who do that sort of thing, saying, no, 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 we need essentially retina resolution, right? We're in a VR headset here, and I look over there, and it's kind of clunky and pixely. But there are headsets that cost a lot of money where, yeah, there's no pixelization, and you can build 3D environments that look photorealistic and pretty much,
Hmm.
like the car ads. When you see a car ad, you've never seen a real car. You're seeing a fake
You're
car that was generated in 3D.
right.
um, so that technology's been around for a while, but now it can happen in real time. And now it can happen in a VR headset with stereo vision that I can walk around in, and I can go and, look really up close. But to get to the point, I can sit in the car
Yeah.
and I can dial in how tall are you? And oh, look, how much do we need to be able to adjust the seats up and down and back and forth to accommodate
Right.
the shortest person and the tallest person? You know, how how far forward and backward do you have to go for their legs to reach the brake? Blah blah blah. Given all those different configurations, can I see all of the vital instruments from the shortest person's point of view and the tallest person? So that can all be simulated now easily without any real outlay of money. And like you're
Right.
saying, in the old days, they had to like redo the car, or they would actually have to physically raise
Build.
and lower the seats, and it was significantly more difficult. So again, it makes it inevitable. Business is going to look at that and say, should we do this the old way, or should we do,
Right. Yeah.
they're
I
going to
mean,
be
even on the
critical and they're going to
marketing
be
side, right?
skeptical.
It's like, you know, yeah. But you go back to the idea of the car, right? On the market side, like once the engineer has built the car in a 3D environment that again we'll call it the digital twin. That could be used as an asset, as an augmented reality to the consumer, where the consumer can say, "Hey, I might buy this car. I'm going to pull it up into augmented reality, put it into my driveway, see what it looks like, and physically walk around the car because it has occlusion. You can kind of see how it looks
Yep.
uh, in your environment, and you could even sit in the car if you wanted to. And again, as a consumer, have an idea like, is this the car for me? Is the dashboard too?
And
Before you even
and that's
step
sort
foot
of,
on the lot, which is
again, it's an extension of a process that they've had all along. I mean, they've used models all
yeah,
along, uh, and and that extends from product design through marketing, and it actually goes both ways. I mean, product design doesn't necessarily start with the engineers. Product design actually probably starts with the marketing people
Yes.
going, we could make
What is
50,
what the
50
audience
different
want?
kinds of cars. What kind of car are people going to buy? And then people say, we want a car with big, long fins coming out the back.
Yeah.
Then they go to the engineers and go, okay, you need to produce a car with fins coming out the back. And then the engineers start to
Right.
go, geez, how do we do that given the EPA regulations and mileage? And,
Sure.
how do we make it possible? So in that case, the 3D model probably came from marketing, you know?
Right. Right. Yeah.
And then,
So
engineers got to tweak it and do whatever they got to do, but they got to keep the same look and feel,
right.
and make it viable.
So,
And
so, so go ahead.
no, I was going to give you an example of that, but I forgot it as soon as I started to give it.
Uh,
So go ahead.
well, so switching to this idea again, we're talking about digital twinning, and we're talking about obviously these consumer, whether it's a vehicle or a product, but now thinking about sort of an industrial, sort of a warehouse side with robots and sort of the idea of, automation is something. It's a conversation that we're all having, right? What is automation doing in the workforce? What's it doing for the warehouse? What's it doing in retail? And so how does XR play a role in automation and that digital twinning of a warehouse?
Well, I could play a lot of different roles depending, if you're the manager, like I was talking about earlier, you're in your office and you want to go and
Hmm.
monitor 20 different workstations. So there's one view that you could have. But if you were, there's a term called cobot now, which is like a robot that works with a human beside it. And,
Called a
you
cobot?
know, I believe that that's the
Ah,
term. Yeah,
I
cobot.
never heard that.
Um, like a pair, it's like a pair, a human working with a robot. And you could potentially have a human working with four robots. You know what I mean?
Hmm.
That's sort of one of the advantages. So, you know, I don't think robots are, well, for some cases, robots are totally ready to take over. That's assembly line, and doing
Right.
exactly this. There's a lot of trying to use robots for creative tasks or less
Hmm.
repetitive tasks. I see attempts to do it all the time, but I'm not, I don't think it'll happen as fast as they want. It's just sort of like self-driving cars.
Right.
There's level 5 self-driving cars that are totally can drive by themselves, and there are instances of that. But the same technology that goes into self-driving cars, there's a
Hmm.
whole bunch of sub-levels of self-driving cars where, okay, hands-free, there's a human behind the wheel. And technically, I don't think Tesla's even supposed to be level 5. They're supposed to technically have a human behind the wheel
Hmm.
monitoring everything. But again, there's lots of other spill-off technologies from that, like accident avoidance, lane departure warnings, and all those things that a self-driving car needs to have. But before we get to self-driving cars, it's useful to give it to humans and say, hey, like we can put this thing in your car that tells you if you're drifting out of your lane, or if you're about to, if somebody brakes suddenly in front of you and you're about to hit them. And in fact, we're going to put the brakes on for you. Like
Right.
it's partly, it's not self-driving, but it's self-accident avoiding, right? So before we get to the place where everything's done by robots that we want them to do, any dangerous jobs,
Hmm.
repetitive jobs, things people really don't want to do, we're still going to need people to work beside them
Hmm.
and monitor them and correct them and perhaps do the last bit of the task that is a little,
Right.
it's not, the robot can't quite do. So I don't know if that addresses your question. Did you actually ask me a question, or am I just
Yeah,
rambling?
but ultimately, right? But ultimately, though, the idea of cobots or robots, however you want to put it, are there to help make the workflow for the human side easier. They're there to assist. They're there to um it's not about taking away jobs. It's about making it easier on the human part of the workforce.
Well, in a sense, it is about taking away jobs. But I mean, I
Hmm.
referenced a show last week called How It's Made, right?
Hmm.
So is an assembly line a robot? Or any of those
True.
things that
Mhm.
and you look at that show and you see, okay, well, they got an automated process for making soup, but there's a human measuring it out and there's a human tasting it at the end and whatever. So the machines serve humans, you know,
Right.
and that's going to be true always. Machines are,
Mm.
we build machines to serve us. That's kind of the
It's
bottom
interesting.
line.
Yeah, yeah. It's interesting. There's again, as I think in the early days of this, again, metaverse conversation, right? In the early days of in virtual reality, when we started seeing how people were using it and how companies were using it and how industries were using it. And of course, there was a lot of work in robotics at that time. Um, and there was always that conversation of like that robots, especially in these type of environments like a warehouse, would absolutely eliminate human need for the workforce. But I always disagreed. I always felt like, no, no, you need to have a human has to be present. The human has to be part of it, part of the process. And in this world of sort of digital twinning and the idea of digital twinning a manufacturing plant or a Target store, or anything like that, that robots and the the virtual version of that organization or industry actually would benefit everybody else. I think it would actually help not only just the workforce but the consumer. I think it would, and I think it overall would help with companies retaining a better ROI and retaining sort of even employee happiness and
Well,
satisfaction.
and the consumer's getting better service as a result. And I mean, warehousing is a perfect example because that's something that, they're definitely trying to automate warehouses. But I got asked the question, why wouldn't we want to automate warehouses? I mean,
Yeah,
I'm
yeah,
pretty close. I've been pretty close to the space of warehouses, and it's like, you know, all the warehouses is you just give it a box and you go put this somewhere until I ask you for it again.
yeah,
And humans humans can never outperform robots in that task, nor should they. It would be dangerous as hell.
it,
I mean, everybody's seen
absolutely.
footage on the internet of the forklift operator tipping over
Tipping over,
20
yeah.
things, and the
It,
statistics on warehouse accidents are
and
crazy.
it's
And that's
similar. So,
something that
yeah.
FS Studio specifically did, automating forklifts because
Hmm.
they're very dangerous.
They
They
absolutely are.
but I will say one thing: there was still a human in the loop.
Oh, so years ago, I had a job. It was like I was a younger, I was much younger. I worked in a warehouse. I worked for a Lowe's, in a warehouse, where you're stacking up fertilizer, you're stacking up lumber, and we had a forklift, and of course, there's a lot of things involved with that, right? So you drive a forklift, you have to be a certified to drive the forklift. And then when the forklift is going and it's moving something, you have to have like two people on one end. They have to block off, coordinate all this other stuff. And then there's the dangers of like there's a lot of dangers, and just like stacking up. Once you put like a pallet of fertilizer on the ground, you have to pick it up. It's backbreaking and it's brutal. And like you said, right, like a human does not want to have that job for that long. Where robots or cobots, could help play a role in that. And so you had mentioned that FS
I,
Studio
yeah,
has done
I
work in
mean,
this area.
call me a lefty, but my thing about humans is we should be educating humans. We should be giving them, high school and college, and then we got all these individuals that are creative that can think of these new ideas and can expand the potential of mankind. Raising people and then putting them in a warehouse job and saying, "Well, you should have that warehouse job your entire life."
Yeah,
That's pretty. That's condemning them to a pretty bleak existence. You know what I mean?
yeah.
I
I mean,
have higher aspirations for people than doing robot work.
yeah. I mean, and if you think about robot work, right, the idea is, instead of having a 9 to 5 shift or whatever shift, I mean, robots just go. They just go. They might have to recharge, but there's another robot coming in, and they can be easily monitored. And so, I mean, this is the argument of why industries or why a company should at least be considering exploring the idea of a digital twin, or because it's better for the workforce, it's better for the company. You're going to have less mistakes made. When you're using this sort of automated process that combines XR technology, that combines robotics but also a human element. Like, let's not forget that part of it, right? 'Cause I think that's important.
Well, yeah, and again, if you can automate all the drudge work out of your processes, and you still have that money, and companies probably aren't going to do this. I realize
Yeah.
it, but they could take the money they previously spent on the low skilled jobs and
Hmm.
and get higher skilled jobs. You know what I
Yeah.
mean?
Yep.
Raise the company, expand what the company does to less mundane grunge
Right.
filled.
Is is
You know what I
is
mean?
there is there you had mentioned some digital twinning work that FS Studios does. Is there anything that you can talk about here, or maybe talk about without
In
mentioning a
vague
name?
terms, I mean, I can go back pretty far, and
Yeah.
we work with one company who was trying to make, well, and it's actually a great example of the marketing to engineering reversal. So it was a toy company, and they made drones, and they'd come up with a new design for a drone that was really novel, but
Hmm.
the question was, would it be able to fly, and would it be able to work, and how would it perform? And it was going to take them at least 6 to 9 months to get a prototype made and shipped over that they could actually fly and try out.
Hmm.
But they couldn't wait 6 or 9 months, try it out, and then decide to change. They needed to proceed in parallel. So we built a digital twin of the toy that was
Okay.
that is based on it was physically correct. It had like basically an algorithm driving each motor depending on the speed of the motor. It actually even made the correct sound based on the how fast the motors were spinning and that kind of thing. And it it the algorithm figured out how much
Right.
force was produced by each one, how much the model
So it
weighed,
brought real
sorry.
physics into it.
Yeah. And so using that, they determined that it would work. It had this quirk, and it was basically just sort of like sitting on the ground. It was in a relaxed position, but then when the rotors spun up, then they would sort of rotate up so that they were above it and then start lifting. But there was this thing where they had to do this first, that they were kind of
Hmm.
curious what the effect would be. And our algorithm predicted, or basically showed, that it would kind of lift off and it would move forward and then stabilize. So
Hmm.
most drones, you take off and it just goes straight up and it hovers, but this one would have to go forward a bit before
Oh.
it could straighten out and hover. And they figured that wasn't going to be a big deal, that was acceptable. And in the end, when they got the real thing, that's what it actually did.
It
So
actually
for
did
me, I
that.
was kind of like freaking out because I'm going, no, no, I made this thing and it predicted this is going to happen,
You're
and that's
right.
exactly what it did. But that's a perfect example of marketing saying this would appeal. This is an appealing
Right.
toy that it's not like every other drone,
Right.
but will it work? So
Cool.
that's
And you were able
answering
to
the question
determine
for
it could
marketing.
work.
Yeah.
Yeah, and you were able to say through the digital twin, the prototype of it, that it was going to go forward slightly. And of course, when it was actually built and created, it did exactly that. Because based off of the
But we
sort of
determined
design
the
that you were
motors were
using.
strong enough to lift it, and
Yeah.
and all the other things as well. So
I was looking at the FS Studio website, Third Wave
what
Automation. Were you part of that project?
weird wave? No, that's the forklift thing, right?
That's the forklift. Yeah.
Yeah,
Yeah.
no, I wasn't. But I know a bit about it, but it's
Yeah.
we sort of went over it. I mean, it's a very
Yeah.
dangerous.
Yeah. Dangerous. Yeah. Yeah.
Forklifts
I'm
are
just
very
curious.
dangerous. There's a lot of
Yeah.
industrial accidents. Basically, it was creating a simulation that had high enough fidelity for
Oh.
the sensors. Like, for example, okay, so you and I are in V here. I can look around and there's a bunch of
Yep.
scenery. What's the infrared signature coming off that little fire over there? Nothing, right? We're not bothering with infrared or
Yeah.
ultraviolet or any of that other stuff, right? for robots, they use infrared, they use ultraviolet,
Yeah.
they don't necessarily use visible light. So there's special, to create a digital twin of an environment that you could train a robot in. You have to understand the robot. Like self-driving cars are being trained in virtual environments. They use
Mhm.
LiDAR,
Yep.
So the environment that the 3D environment that you're providing for it needs to be able to simulate LiDAR, right?
Hmm.
And that's not something you normally do for a game like this. There's no LiDAR return coming off of you and that kind of thing.
Right.
Creating a digital twin
Right.
depends on you knowing who's consuming the information, right?
Right.
And that's why VR isn't like, is a robot in VR? You know what I mean?
Right.
Is that VR? Sure, it's like a 3D world, like I was saying, but
Hmm.
the robot isn't wearing a VR headset.
Right. The
You
robots.
know,
It's robot's a robot.
it might actually have 10 eyes,
Yep.
2 infrared eyes and a bunch of LiDAR eyes. So it's not VR like we think of VR,
They're how we
but
see it.
it's
They're
spatial
seeing the world.
computing for
Yeah,
sure.
they're using spatial computing. I mean, which is interesting. I love LiDAR. So I know some people, maybe some people know, some people don't, but your phones have LiDAR. My Apple phone uses LiDAR. Your facial recognition is basically LiDAR, but I love using it to scan objects in the real world and creating a instantly uh, digital representation of my living room. And it's done pretty quickly, done pretty easily. And it's amazing that's built into phones.
Yeah, and I mean, not all phones have LiDAR. I mean, those
Right,
are,
not all of them.
very, and
Yep.
anything in the last 2 or 3 years probably does. But no, it is amazing technology.
Is it like light detection radar? Is that what it is? LiDAR? I can't
Yeah,
I can't remember what the
light
term was.
detection and ranging.
That's
DAR is
okay.
detection and ranging. Um, so LiDAR is light detection and ranging.
Okay.
Um, and the reason it's used is it's very fast and it's very accurate. But it doesn't have a very high resolution because
Right.
it's a point cloud. So, I'm shooting a beam here. I'm shooting a beam. Let's say Alan. Hi, Alan.
We're
I'm
shooting
shooting a
Alan
beam
with
at
beams.
Alan. Okay, and I can go. Okay, well, over to the right hand part of his head, it's 3 feet, and then to his nose, it's 2.9, and then over to the other side of his head, it's 3.1. And there's only 3 samples there, but
Right.
basically, I'm casting a ray and I'm getting a distance. And that's great because he's only, a few meters away. But if he was 100 meters away, chances are
Right.
I would miss him. Would be
Right.
in between those 3 beams. So the farther away you get, the less useful LiDAR is. You know what I
Right.
mean? It's useful up to a certain distance. And then even within that distance, you need to have a very high, bam, 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 bam. You need to shoot out a lot of rays
Hmm.
to get enough measurements to do
It's a
something
lot of data,
useful.
right? It's a lot of data points, basically.
Yeah, and for a car, they don't really need to look up there. They
Well,
need to kind
it's
of
like
look at
what's happening
this
below.
level. So they're shooting out like a fan-shaped ray of beams that that cover in front of them and to the left and the right. They're not really looking behind or to the side or up or whatever.
Hmm.
Whereas you and I just look there and we can see it all
Right.
in our view immediately, right?
Right. But there's definitely those like parts where the human body is better than technology. Absolutely. Like we can see farther than LiDAR. We can, uh, but again, the combination or the blend of the two, with technology, with a human operator or a human assistant or or a robot assistant. I don't want to put us in a situation where we're assisting robots, but that is sort of more the ideal approach in how we should possibly move
Well, yeah,
forward.
I mean, the thing is, we take in a lot more information than our brains can process, and we have all these filtering systems that and there's optical illusions are based on this, where it's like
Hmm.
I could be looking at Alan and they could say there's a tiger right there, and for some reason, because Alan's wearing a zebra shirt, I don't see a tiger, and that's your brain going, oh, if
Oh
there's a
yeah.
zebra, we're safe, and there can't be a tiger, or some weird stuff going on in our brain
Yeah,
that
our brains do
filters
weird
things
things.
out that that are in our perception, but we just ignore them because our brain says that's not there or whatever. So there's there's that, because the me in my brain can only process things so fast, but all these filtering systems can process things very quickly and filter them out. And the same thing exists with machines and robotics. Let's say, um, you know, if costs weren't a factor, I mean, we get the cost of these LiDAR cells down to almost
Hmm.
nothing. Then we could put a thousand of them, a big array of them in front of the car, and put a little processor for each one. You know what I mean?
Right.
So that we don't have to have a major CPU going, oh my God, I've got all these LiDAR sensors and I got to sort them out. No, that LiDAR sensor sitting there going ping, 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 nothing, 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 until it sees something that's within a
Physical.
certain distance
Yeah.
of it. It's not going to report, right? Or
Right.
whatever. Same thing with machine vision. You know, then they're training machine vision to detect, oh, I see a human. You know what I mean? To
Hmm.
classify what they see. And the thing is, if they could just throw processors at that. You can
Sure.
just go, here's a processor that detects humans. Here's a processor that detects kitty cats.
Hmm.
Here's a processor that detects fire hydrants. Here's 5 processors that all detect traffic lights. You know what I mean?
Right.
So there's some things that we can just throw CPUs at that will act like filters for the main
Sure.
brain, so that or even for the human, if the human's still in a self-driving car, you have all these systems monitoring until all of a sudden one goes beep, hey, there's a human about to walk into the
Right.
road, and then the human can go, oh, I can deal with that because it's only one event. You don't have
Right.
to deal with a million
You're
events.
you're basically taking your you're sort of allowing your brain to process more information by actually having to do less, in a sense. Like, maybe that's not the best way to put it, but
Well, it's hierarchical. I mean, and it's
yeah.
like sort of it's control systems. When we say control systems, you have a control system that's controlling one thing here, uh, and what it's controlling, let's say, is a temperature, but then you have another system above it that's saying
Mhm.
what should the temperature be. So the system that says what should the temperature be isn't actually doing anything to make the temperature be that, other than
It's the other
tell
system.
another system, I want you to
Right.
keep this temperature at this value
Yeah.
or whatever. And that's how robots work. So you have a robot as a hierarchy of joints, and the shoulder joint has an elbow joint and a wrist joint and a whole bunch of finger joints under it.
Mhm.
And the job of software guys like me is to figure out how to make sure that each element in that hierarchy doesn't only has to worry about its own thing.
Mhm.
You know?
Right. Right. It's like, interesting. So you talked about we were talking about a little bit about the brain, right? And the whole thing about what virtual reality in the brain, right? Is like when we go into a VR headset, our brain looks at the environment as if it's a real environment. Like when I walk through a crowd, I will walk around people, even though they're virtual. Like I will still walk around them, or or when we do training, we put people into dangerous environments in virtual reality because their brain perceives it as it's an actual dangerous environment, and so they try to do the job correctly. They try to make sure they don't make mistakes, but they get all the emotional impact and the empathy, but they don't have like a real world consequence, right? So which I think is really fascinating. But again, you were talking about how the brain works, how we can trick the brain into thinking one thing. We can into thinking that Alan's a tiger, or we can trick the brain into thinking like, that standing on the ledge in virtual reality, looking down 100 floors is real. Like we get nervous, and I know if you ever done Richie's plank, you ever done that?
I've never done it, but I heard about it and I went, yeah, for
Yeah,
100%.
it is. It is one of the most
Go. I mean,
terrifying.
explain to Alan what it is.
Yeah. So Alan, so Richie's plank is a virtual experience where you up an elevator up to like the 100th floor of a building. So you start off on the first floor of a building. You walk in the elevator. You hit the elevator. You go up to the 100th floor. Doors open, and when the doors open, it's just an open door that leads out to a plank that's like above the city, and so you have to walk out onto the plank, and as you look down, you see, the ground way below you. You see the sky, and a helicopter flies past you. But you get all these feelings. You get that nervousness. You get that anxiousness. You get that fear. Like you get legitimate fear from standing on the plank. And I've actually so a bunch of years ago, I would do virtual reality demonstrations at these education conferences, and I had actually somebody who was deathly afraid of heights, and he would live in London, and it was like he always told me like there was this one building in London he always wanted to go to, but it was really high, and he just could never do it. And so off, during after hours at the conference, we'd get together in a room, and I would he would do the Rich's plank where he first got up to the elevator, let the door open, and that was it. And then like the next day he would like take a step out, and you could see him. He got very emotional. He would shake. He would physically shake from staying up there, and at one point he just got just like he like just was engulfed in fear. And we did this for like 4 days of the conference, and every day he would step out. At one point he stepped out a little bit closer. Months later, I get an email from him, and it's a picture of him on at the top of that building that he's always wanted to go to, because he
Cool.
used VR to help him sort of get to that point where he was able to at least get to the top floor where the doors open, walk on the vestibule that was there, and that was like a empowering moment of how VR
Wow.
could help somebody get over. And it was really
Yeah,
amazing. But
and
again,
that sort of makes sense because it's like
yeah,
in VR, it's like, oh my God, if I can just go out on a thin plank 100 meters up and that internalized to his ear centers and everything. And so he's thinking, well, if I can go out on a plank 100 floors
yeah,
up, I can go out on a big vestibule 50
yeah,
floors up, right?
yeah.
And I just want to sort of segue a bit and say where a 2D, this is where the difference between VR and a 2D experience plays in. Because I've played tons of games, like Far Cry games have things where you climb up towers and they
Mm-hmm.
try and trigger the vertigo. And you do get a bit of vertigo, but there's the TV or whatever. I can just look over there and it's like, no, I'm not.
Right.
But if you do that in a VR headset and you don't have that external frame of reference, you
You
can't
are.
you can't
Yeah.
shut down your
No.
lower brain. That stuff comes from your lower brain. So, like I say, if you're watching a TV, your higher brain can override the lower brain and go, no, 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 it's a TV. Look, the stuff to the right of the TV is not, it's not, we're not 100 stories up. But if you get that in a VR headset, your higher brain can no longer override your lower brain. That's why people get sick. That's why
Right.
vection happens. If you're in a car, it's exactly the same situation as being in a VR headset. If you're in a car, many people when they're young get car sick, but when you're young, you can't see out the windows. You don't have a frame of reference. You're in the back seat, and all you know is you're
Right.
moving, you're not moving, you're turning. Once you can sit up enough to look out the window,
You can see you're in motion.
then you can see, okay, the world is moving by. So the fact that I'm moving makes sense. But yet I can see the frame of reference of the car, so I'm safe and I'm stable and I'm in this, I'm not moving with respect to the car. So that's how you get over car sickness. Vection is exactly the same mechanism. It's when your brain feels like it's not agreeing with the motion. So in
Mm-hmm.
this case, it's not moving and the world isn't moving. It's like the world
Right.
is moving and you feel like you're not moving because you're not moving. You know what I
Right.
mean? And that's why we have all these mechanisms like teleporting and
Mm-hmm.
whatever instead of directly drive, like in a
Like the
2D
foot
game.
drive or whatever. Yeah.
Yeah, in a PlayStation, I'm continuous motion. I'm running around. When you come into VR and you try and do that, that's when people
Oh,
start to get sick.
that's
Okay,
that's when
so
I get sick,
that's where the
man.
difference between a 2D, seeing a 3D world on a 2D screen and being in the 3D world and experiencing it in VR
Right.
are two
Well, it's
very
interesting.
different things.
There's definitely some VR experiences that I can't do. Like again, and I don't do well in the experiences where I'm either flying a jet or driving a car because I just I struggle with those type of experiences, but I can experience like this or walking through or playing Beat Saber. Uh, uh, Teleporting obviously has absolutely helped me maneuver through virtual reality experiences. But if I were to use the walking mechanics, I don't do well in those type of situations.
Mm. Yeah, and actually, it's weird. You mentioned flight simulators for one thing. We've had flight simulators for a long time, and the whole thing about those is you flight simulator fanatics. They always have been trying to surround themselves with
Yeah.
monitors so that they can
Hmm.
basically feel like I am in the airplane, but you're moving very slowly, and that's another factor of vection. I mean, if you, if I were to take your out, if I were to take your avatar and let you walk around in a world, and I made you 20 feet tall, you wouldn't feel much vection. But if I made you the size of a cat, you would feel a lot
Right.
of vection
That
for
would.
the same speed.
Right.
Because
Right.
the world's moving by you faster it makes you feel vection more. And that, but in a flight simulator, you're up in an airplane 1,000 feet in the sky, so the world's going by very
It looks like it's very
slowly, and
slowly. Yeah,
yeah,
much like again, unless you were, you came lower and you could,
unless
you
you're
level to the
landing,
ground.
yeah, that's when
Yeah,
the world starts shooting by a little.
yeah, yeah,
But
yeah. 'Cause-
but in that case, I mean, in a flight simulator, generally when you're landing, your tunnel vision focused just only on what's directly in front of you, so you're not focusing on all this stuff rushing by you. Does that
right.
make sense? You kind
Yeah.
of like, if you land right, you're focused down. You're always focused down the runway, so you're always looking at something that isn't coming at you really really fast. That
Hmm.
makes sense.
Yeah. No, it makes sense. I get it. Well, look at we're at the top of the hour, and Pete,
Oh
it
yeah,
is always, always a pleasure talking with you about this stuff.
you
I
too.
enjoy our conversations, and I actually learned quite a bit today. I had no idea about cobots. Um, that's something, but we dove into a lot of information. We talked a lot about the metaverse. We talked about digital twinning and manufacturing. We talked about robotics. We talked about
Spatial computing.
automation, and we talked about spatial computing. A ton of stuff. And of course, if anybody has any questions, anybody wants to know more, we ask to just reach out to us. You can either post a comment on the social media link, or even drop an email or whatever you'd like to do. So Pete's a plethora of knowledge and information. Looks like Pete's arm is looks like your battery might be going, Pete.
Does it?
But
It look okay to
yeah,
me,
yeah, but
but I
Pete's
wouldn't
like
be surprised.
a ton of information, and we always appreciate everybody interacting with our content. So thanks everyone. Thanks, Pete.
See you
Rock
next week.
on. See you next week.